Hi everyone. In this video, what we're going to do is start talking about the unit circle. Um, so first, why the unit circle? So in our previous video and activities, we looked at a bunch of different circles and circular functions associated with them, centered at all sorts of different places, different heights, different radii, whatever. But circles aren't really that different from each other. Most circles look pretty much exactly the same, except for some scaling and shifting. And so, what we do in mathematics often is when you have a whole bunch of different types of things, is you just spend a lot of time studying the one simplest version of that thing, and then every other thing is just some modification of it. So, in our case, our um, circle of choice, the easiest possible circle is the circle centered at the origin, radius is 1. So that's going to be the circle that we focus much of our attention on in this class. Um, and so what we'll notice about the unit circle is that you have you can traverse a point along its circumference, just like in with the Ferris wheel, except our convention is that we start at height 0. So we start here over to the right, whoops, and then we kind of go around like that. And so uh, what I'm gonna start with in this video is the discussion of angle measurements. In previous classes, you're probably familiar with the idea of degrees and 360 degrees uh, in a complete circle. And in this class, what we're introducing is a notion called radians. And you can read more about the details of radian convergence in the text, but uh, a natural question one might ask yourself at this point is why why introduce a different measurement for angles and for circles if we already have a notion of degrees and we already have like this 360 degrees to make a full circle that everyone's familiar with. Um, well, frankly, degrees are kind of a terrible um way to measure angles, especially angles in a circle. There's nothing 360-ish about a circle. It's just a number we made up. And mathematicians really just made up a big number that can be divided by lots of stuff and then just chop the angles into that. But it could have been 400, it could have been 900, it could have been 25 trillion. Like, there's nothing inherently 360-ish about circles. But uh, when we say that a all the way around a circle is 2 pi radians, what we're saying here is, and so here theta is our uh, this value times pi is our angle. Um, Look how far it takes to go around a circle, right? If you were to go all the way around the circle, you would be traversing the entire circumference. And the circumference of a circle is 2 pi r. And in this case, our radius, is 1. So it's just 2 pi. So if I go around 2 pi, that should be the whole circle. So in a sense, what we've done here is just associated the angle of some ray associated with the circle with the circumference. All right. So this angle here, let's say it's, let's try to get it as close to 2 pi as possible, or 0.2 pi. Let's say if this angle here is about 0.2 pi, this arc length here is also 0.2 pi. We want the angle and the length to be the exact same thing. So if you're 2 pi all the way around, then here we've gone 1/4 of the way. So we should be at about a 1/2 pi. And then 1 pi. And then 1.5 pies. And then 2 pies, right? 2 pi for the angle, 2 pi for the circumference. And that's why in this class, we will tend to use radians in our arguments. And if you advance into future math classes, radians will tend to be the degree measurement of choice. But it really is the most natural measure. It just says, hey, your distance around, your angle, that's the same thing. It just makes sense. All right. Thank you. See you in the next video.